So, the topic we are going to study now is digital logic gates. So, this is one of the easiest topic in this module. In fact, everything is easy itself. It's just your mindset. So, just practice well, and everything will be easy for you. So, in this digital logic gates, you can see here 3 gates have been introduced over here. Okay. So, you know about the AND gate over here, and this is the OR gate, and this is the NOT gate. So, if you see in this part, the AND gate, OR gate, NOT gate, which you have already seen previously. Suppose your input both are 0 0, so just multiplication of these two numbers 0 into 0 is 0, 0 into 1 0, again 1 into 0 0, only 1 into 1 is 1. In the subject, how we say is, if both the inputs are high or output is high, otherwise it's 0. And for coming to the NOR gate, if either of the input is high, your output is high. If both the inputs are low, only then your output is low. Simple thing. And here it will be opposite of your input. That's it. Coming to NAND gate. So, in the NAND gate, you have just the complement of whatever you get here. Okay. In the AND gate which you get, uska complement is nothing but your NAND gate, and the same thing which you get in NOR gate, its complement is your which you get in OR gate, its complement is your NOR gate. So, you can see here we have written A into B the whole bar. So, here we get A B, right. That whole bar is nothing but here, and A plus B what we have here, that whole bar is nothing but see A plus B, that whole bar you have to put here. So, this it's I guess it's simple for you. Only the difference here we can see is logic gate is also same. You will just have one small circle in the output side, and here also we will have a small circle in the output side for both the AND gate and OR gate, except that you have here XOR gate. So, this is one interesting gate over here, and one question I think most probably they will be asking from this. The symbol is just you have to draw the OR gate, but another curve before that. That's it. So, this is your XOR gate, and here same like A plus B itself it will be, since OR gate is there. The difference is that plus will be in single. So, that is the exclusive symbol which you call. So, how to understand? So, see here, if both are 0 it's 0, both are high it's 0, remaining it's 1. To understand this, XOR gate is nothing but you will be having an equation here, A bar B plus A B bar. So, now see, let us do this equation, or solve this equation. So, 0, both are 0. So, here it will be what? A bar is nothing but 1, 1 into 0 is 0, plus again here 0 into 0 bar is 1. So, anything into 0 is 0, like that. So, if you take this condition here, let us put this here. So, 0 bar, what is 0 bar? 1 into 1 is 1, plus, so A is 0 into B is 1, 1 complement is 0. So, this term will be 0, but here we will get 1. So, that is why 1 will come here. Similarly, here also 1, and here also 0. So, like that we are taken the output side here. So, this is how the output comes from this expression. In previous lecture, in one of the lecture I have explained how to substitute the values for this and then write it. So, that is how is a basic introduction for all these gates. So, here we have NAND and NOR implementation. So, this is the most important topic, how to convert the given basic gates into the NAND gates. All should be NAND in format of NAND, and then we have to write in the NAND format or in NOR format. So, let us begin with that. So, suppose you have there is one question for us here. Okay. So, let me take the question first. Let us go with this question itself. Okay. So, they have given conversion of AND or OR logic gate into NAND or NOR implementation. So, how the question will be asked? Implementation of Boolean expression using NAND or NOR gate. So, they have given y is equals to A plus B dot C dot D. So, here the whole bar is for C. Okay. So, what will be the basic logic diagram for this? First, what we want, A plus B into C into D. Okay. So, first we need A plus B. So, we need a OR gate for adding A plus B. So, here I will write in the side A B. Then we have to multiply that with C. how will we do that? Using one AND gate. Okay. So what will be having here? A plus B. Here what will have? Okay, here we will have A plus B into C. Okay. So here we will have A plus B into C, the whole complement. Sorry. Okay, now it will be visible. So then we have to multiply the whole thing with D. So simply just take this here and put here. So now we will get A plus B into C the whole bar into D. Okay. So this is the basic logic diagram for this expression. Now what we have to do? We have to convert this into NAND gate and NOR gate. So let us do that. So here I have done that, but I will be doing again in this thing, and then I will explain to you. So let me divide this thing into two, so that in one side I can do NAND implementation, and on the another side I can do NOR implementation. So first we will do NAND implementation, and remember that there are some rules for this. So I will explain the rules for you here itself. So what are the rules here? So suppose you are implementing NAND implementation. So let me erase this. Okay. So suppose you are doing NAND implementation. Remember, for NAND implementation, if you understand one, the opposite of it is the another one. Implementation. Suppose you have one OR gate, okay, and then again I will put another OR gate, just an example, then I will connect it with AND gate. So let it be anything. So we don't want what variables it's having, just explanation of for just example sake. So we are doing NAND implementation. Okay. If you are doing NAND implementation, remember one thing. So this is your NAND gate, right? After your NAND gate, you will have one circle. Okay. And before your OR gate, for both the input lines, you will have one circle each. Understood? So this is a rule. Okay. We did this. First what we will do, we will add the bubbles. You can call this a circle or bubble. You will add the bubble for in NAND implementation after AND gate and before OR gate. Okay. And wherever you have placed a bubble, you have to put one NOT gate. Okay. One NOT gate you have to put. For this bubble I have put NOT gate here. For this two you have to put here. Okay. This is the second thing. What is the second thing? You will put the NOT gate wherever you have put the bubbles. Now what you will do? Now you have to replace here. So suppose you had the NOT gate, that will get converted to this kind of sorry, not like this, like this kind of NAND gate. And suppose you have OR gate of like this, that will be converted to NAND gate like this. That's it. This gate will remain as it is. So now I will draw a small diagram how this will become. So this will be like this. Again we have one NOT gate over here, and I forgot to mention another rule. Suppose we already had one NOT gate over here, we wanted a complement function, so we get two NOT gates, right? So if you have two NOT gates, you can just cancel that, no need to write itself, just remove it. So here you will have another NAND gate like this, then this gate like this, so this like this. So here directly you can write like this, and this directly like this. So this is one small basic, like just I have explained you how the things are happening in NAND implementation. So I will write once again. So first what will happen, you will have to put the bubble. If AND gate is there before that, if OR gate is there, say after AND gate we will put one bubble in NAND implementation, before OR gate two. Then wherever bubble you gave, we have to put NOT gate. Okay. And then you have to convert the NOT gate into this, and then OR gate into this. That's it. The same vice versa happens in NOR implementation. So what happened in this? Before AND gate you will have two bubbles, and after OR gate you will have one bubble. Same, wherever you gave the bubble you have to put the NOT gate, and then at the end this will get converted into NOR gate like this. That's it. and this NOT gate is there, right, that will get converted to same kind of NOR gate like this. I mean NOR gate. So, here only AND will type symbol will be there, here NOR type symbol will be there. So, this is the basic general knowledge you should be knowing how to implement NAND or NOR implementation. So, now let us continue with the given question which we had here. So, here I will draw the diagram first. I won't focus much about writing the expressions whatever we have, just for you to understand I will write here and leave it. So, here I will get a plus b, here a plus b into c, and here a plus b into c the whole bar, and here we will have the equation a plus b into c the whole bar into d. So, now NAND implementation. So, you have to write this implementation in stepwise. So, now what was the first thing? We have to put bubble. First let me draw the OR gate here. So, same thing I am drawing here, just I will put one bubble. Okay. After AND gate we will put one bubble, not before. Okay. Okay. So, here was the input for this, and this goes here, and this line comes here. Okay, wherever we had to get. For NOT gate we won't add any bubble, so don't get that confusion. Only for OR and AND gate we will put bubble. So, now what is the second condition you have to do? Wherever you give the bubble, you have to put the NOT gate, right? So, okay, so let us put the NOT gates over there. Bubble won't be removed if you put the NOT gate. Okay, remember that. Okay, like this. The second step. So, see here, we already had one NOT gate here, we will have two NOT gates over here. One NOT gate because of the bubble, one already existing. So, now what will happen if we have two NOT gate in the same line? Same line does not mean like this whole line, after from one end of the gate to the beginning of another gate. So, this you can remove, cancel. Why? Because suppose we had any value here, it will take the complement, another NOT gate will give the double complement. So, it will be the same value again which is coming from here. I already explained this. Suppose you had 1 here. So, so first it will come here, from this, because of this NOT gate will become 0, then again because of this NOT gate will become 1. So, as you can see here, from 0 to 1 again we got 1, right. So, directly we can remove this and directly pass 1 here. So, we will just remove this, and what we did, we have to replace the NAND gate with NOT gate NAND gate. So, let us replace that now. Now, the replacement happens like this. Even here this OR gate becomes like this. Okay. This NAND gate won't change, here nothing will be there, then here another NAND gate. Okay. So, here was our input. At the end just write the equations like this, A B C D, A B C D. I am explaining, so I won't write. So, this was your NAND implementation. So, now let us do for NOR implementation. So, remember, whenever we do the implementation, now I did for NAND, right, I won't take this gate as a reference, I mean this logic diagram as a reference. The first diagram which I did, that itself I will take as a reference and implement for NOR also. So, now let me start implementing for NOR. So, first what I have here, OR gate I have. So, what will happen after the OR gate, we will have one bubble. Okay. Then here we have AND gate. So, before AND gate we will have one bubble as we had studied. So, here we already have one NOT gate, and again we have one AND gate. So, we will have one bubble here like this. So, this is input here and this will go here. Now, what is the second rule? We have to place a NOT gate wherever the bubble is there. Okay. So, here we will have one NOT gate and we will have another NOT gate because of this bubble. Here one bubble NOT gate, here one bubble NOT gate. I will put in one line itself, then I will take this down. Okay. So, here like this. Then now again you can see we already had one NOT gate, we will have another NOT gate because of this bubble. Okay, so wherever we had to give the bubble, it's over. Okay, I forgot to put one NOT gate here and another NOT gate over here. Okay, so wherever we gave the bubble, we added one NOT gate on each place. Now we can see we have two NOT gates over here and two NOT gates over here. Just remove that and replace the NOT gate with the NOR gate and NAND gate with NOR gate. Okay, so here we won't have any NOT gates. Now this NAND gate will convert it to this NOR gate. No NOT gates. Again this NAND gate will convert it to this kind of NOT gate. So what is the basic idea of this is we have to convert all the basic gates into NAND gates. That's why even we are replacing the NOT gate with this kind of NOR gate. We don't want any basic gates. Now you might get a question like, see, suppose this logic diagram we got this kind of inputs. So if we like give here A, B, C, D and we try to get the output, it might differ or it might be same. So it depends on the equation, because like as I had checked once, so it changes. Okay, the equation here we got A into B, I am sorry, here A plus B should be there, A plus B into C the whole bar into D. So this you won't get the same thing here. Okay, it will change, I guess. So this is one of the question, one question we have solved here. So let us solve another question. Then you can I'll solve a complicated one here. So you can see here the same thing I have done here, and we will get the same output here also. So let us do this. It's the important question. So here they gave the normal equation, right? So what they will give the question, implement NAND and NOR implementation for XOR gate. So like just by seeing this question, so what will ask, NAND, NAND, NAND and NOR implementation for XOR gate. So even I did the same mistake in my examination, that by seeing this question I got like confused, like what is this question, they didn't even give any expression or anything how to do this, but this is the easiest question to solve. So as you can see, what is the expression for XOR gate, you have to remember, as I said in the beginning, expression for XOR gate is nothing but A exclusive B. Okay, now you got the equation also A exclusive B, but how will you do the NAND NOR implementation here, because XOR gate is like this, right? Now how you will convert this into NOR gate or NOT gate or anything like that? So that is also a confusion. But we also know that A exclusive B can also be written as A bar B plus A B bar. So here is the biggest mistake people do. They don't think here. Students won't think that we can convert this into this, and they will get confused and leave the question or make mistake. So this is also equals this. Now you have to make a basic logic diagram for this. So let us make that. So A input, NOT gate, which becomes A bar. Okay, then we have B, AND gate. Now same, A goes here. Now we need B bar. Okay, now both will be connected with a OR gate. So here we will get A bar B, A B bar, A bar B plus A B bar. So this is your diagram for XOR gate. Now we can start implementing for NAND implementation and NOR implementation. So let me divide the page. In exam, just try to cover more space. Okay, just don't go for neatness. Just if you can do roughly properly, with good shape, that's enough. Because time is DDCU will take a lot of time to complete, because they will try to fill the paper with sub questions, and it will be a problem itself for you. So now NAND implementation over here. Now again, all the NAND gates, so wherever we have AND gate, we will get one bubble after it. For OR gate, before that we will get bubbles. So let us do that. you take your time and then solve this. I know this concept, so it's easy for me to just draw and go over. Now what you have to do, this is one step, right? In the second thing, we have to put NOT gate wherever we use the bubbles. So let us do that also. uh, Now see here, we have will be having one NOT gate because of this bubble, another NOT gate because of this bubble. So we'll have two NOT gates. Okay. Over. Now from dotted lines show like this, and then you can write one line itself in the examination that two OR gates are there. Just write the, in each step you can write replace this gate like that. You have to write that because or else directly if you do they'll ask that, just one line is enough. Now what you have to do, convert each gates. So NOT gate will become like this kind of NAND gate, AND gate won't change how it is. Okay. So now this thing won't be there, all the gates will will be removed. Over. So this got removed and this got replaced with this. So this is your NAND implementation. So let us do here NOR. Same thing. First we will consider this diagram itself. What happens while you do an examination, you do like this, right? You cannot do like this, you won't be doing like this like me half here. So you will do in the order wise. So last diagram will be this for you. To me, I can aram se see here and do, but for you this is the last diagram. So don't get confused and try to implement from this diagram itself and directly change something. No, don't do like that. It will be wrong itself. So take the reference of this diagram and then do. You have NOT gate here. Before AND gate, you will have two vowels now. Okay, remember that. Okay, here A and B. Now here after this one. Now what will happen, wherever bubbles are there, you have to give one NOT gate. So here you will get two NOT gates. Here also one NOT gate will be there. There is no space, so I have drawn this small because this is B, right? So I could have taken from here, but I took from here. So just take from here and draw neatly in the examination. Over. Then you can see here you have two NOT gates and here two NOT gates. See, I did a confusion where I did not put bubble here. Okay, and I did not put NOT gate here. Don't make that confusion. Do aram se and without any confusion you have to put. So from this diagram you can see here one NOT gate, here one NOT gate, here one, and here. Total 5 you have to add extra. So there should be 7. 1, 2, 3, 4, 5, 6, 7. Over. Correct. Now replace those NAND gates. So here the NAND gate will be deleted. It will be removed, cancelled. So this AND gate will be converted into this kind of OR gate. So here we have one NOT gate that will get converted into like this. Okay. So here we have another NOT gate that will be converted like this, and that NAND gate will become this kind of NOR gate. So here we won't have any NOT gate because that got removed. Here again like this, and now here one more NAND gate like this. Done. Finish. Over. So this is how you do the implementation for NAND and NOR implementation for XOR gate. So don't get confused on examination. If they ask, you can easily do like this. And